Hey, this video is going to go over important vocabulary needed in order to graph trig equations. The first thing we need to know is what a periodic function is. It's something that repeats at regular intervals. Think about a clock. Every 60 minutes, that hour is going to repeat. We're going to go from 59 back to 0, and we're going to count 1, 2, 3, 4 all the way back to 59, 60 minutes all over again. Now we're doing that same thing, that same repetition, but with a graph. Now the period is the length of the interval over which a periodic function repeats. Just like each hour is 60 minutes. That would be the period. So now looking at these graphs, we're going to look to see which ones are periodic functions. In other words, which graphs repeat over and over again. So of the graphs that repeat, I would say graph 1 repeats. It has a very similar pattern. So I would say 1 is periodic. 2, notice that 2 never repeats. 2 is a pattern, but it's not a repeating pattern because it's going to keep going on to get bigger and bigger and bigger. It never actually repeats, it just increases in size. So we're going to say this is not periodic. Choice 3 looks like it repeats. And choice 4 has a pattern as well that repeats. So 1, 3, and 4 are all periodic equations. Now to find the period, it might be a little bit tricky. The way I do it is we are starting at 12. Now we're going to go down. And when I get back to 12, I'm not starting to repeat because now I have to go up. But once I get to 12 there, that's one period because notice if you do it again, it's going to be something that we already did before. So a period, you're going to stop when you start to overlap yourself. And that's where the green meets the purple. That's where the end of the period is because the purple starts to repeat itself all over again. And we're going to say that the period is 365. Now, if you're starting at the bottom and you're going all the way up, you come back down, you get back to where you started. Take a look at what the next step is going to be. You're going to start repeating yourself. And you're going to go and trace over your steps all over again. So that means our first period was from 0 to 0.25. Number 4 is a little bit easier to figure out to see where the pattern ends because from 0 to 6 is one period. And then you're going to start repeating all over again. Now that we know the difference between period and periodic, we need some other vocabulary. The first one we're going to go over is the midline. The midline is a horizontal line located in the middle of the graph. A little typo there. Now, there is a formula for midline, and that formula is going to be max plus min over 2. Get it? It's the average formula because it's going to be the middle. It's your average point on the graph. For example, if you were to have a graph, oops, there we go. And let's say our graph is there. and this is at 2, this is at -2. Your midline is the middle, and the middle is at y equals 0. That is your midline. Going on to amplitude. Now, amplitude is 1/2 the distance between the max and minimum points, or it's also the distance from the midline, the middle, to the maximum, or from the midline to the minimum. Basically, if you were to have a graph, and as before, we're at 2, we are at -2, our middle is at y equals 0. That's the midline. Your amplitude is the distance from the midline to the top, from the midline to the bottom. Anywhere that you go from the midline to the top, all of these distances are 2. That is your amplitude. The formula for that is max minus min over 2. If you want to find it algebraically, but usually amplitude is easy enough to find looking at the graph. Your max minimum is pretty self-explanatory. The maximum is the highest point on the graph, and your minimum is going to be the lowest point on the graph. If you want to find this algebraically, it is your midline plus your amplitude. How high are you going up? If you take your midline minus your amplitude, that is how low you are going downwards. The amplitude is just the distance that you go up and down. So if you take your middle and you apply the amplitude from the middle plus how much you go up is going to be your maximum amount. Going on to your frequency. Basically, how frequent does your cycle happen? It's the number of cycles a function completes in an interval. Now, with trig, that interval is typically from 0 to 2 pi. So how many times does your graph repeat itself between 0 and pi? We are going to think to ourselves, how many? And the formula for that is 2 pi over your period. And again, your period is the interval it takes to complete one cycle of the period function. How long does it take for one cycle is the period? How many cycles is your frequency? The formula for that is 2 pi over your frequency. And you'll notice there is a relationship between the two of them. To find one, you just have to take 2 pi and divide it by the other. I'm going to try to finish these up super fast. Your quarter points are used as labels for your x-axis. You know how usually when you make a graph and you label it 1, 2, 3, 4, we don't do that anymore. Instead, we take how long a period is, we divide it into 4, and that becomes our labels for our x-axis. That is going to be found by doing your period divided by 4. And then last two, easiest two, your increasing intervals are where your y values are increasing. Your decreasing interval is when your y values are decreasing. So if you were to have a graph, and let's say this is what our graph looks like, your Increasing intervals are going to be here and here because you are going upwards as you read from left to right. Your decreasing intervals are going to be all of that because in that whole section you are heading downwards, and you always have to work from left to right because that's how you read. That's it for this video. Tomorrow in class we're going to talk about how to actually identify them from graphs.